Dear student, myself G.U.Patil, I again welcome to all of you for my online lecture series during this lockdown period. Dear student, I have already completed unit number 5 and 6 through this online lecture series. Now, today I am going to start the unit number 4, that is network layer. So, for this today's online lecture, my topic of discussion is Internet Protocol version 4, that is IPv4. Now let's begin with IPv4. Internet Protocol is one of the major protocol in TCP/IP protocol suite. This protocol works on the network layer of OSI model and internet layer of the TCP/IP model. Thus, this protocol has the responsibility of identifying hosts based upon their logical addresses and to route the data among them over the underlying networks. IP provides a mechanism to uniquely identify host by an IP addressing scheme. IP uses best effort delivery, that is, it does not guarantee that packets would be delivered to the destined node, but it will do its best to reach the particular destination. Internet Protocol version 4 uses 32-bit logical addresses. So IPv4 is the most important or major protocol in TCP/IP model or protocol suite. So this protocol works on network layer of OSI as well as internet layer of the TCP/IP model. This layer or this protocol has the responsibility to identifying host by an IP addressing scheme and to deliver the particular data or route the particular data packets among them over the underlying networks. So this IP protocol version 4 uses 32-bit logical addresses. So this is about IPv4. Now move towards the IPv4 packet structure. So Internet Protocol, being a layer 3 protocol, takes the data segment from layer 4, that is transport layer, from the transport layer to the network layer and divides it into the packets. IP packets encapsulates data unit received from the above layer and add to its own header information in it to form the packet. So figure shows us the IP encapsulation, that is the packet structure for IPv4. It will contains the IP header along with the layer 4 data. That data is nothing but the original packet data coming from the transport layer to the network layer along with this header data. So to form packet structure, IP header plus layer 4 data is nothing but the packet structure, that is called as IP encapsulations. Now the encapsulated data is referred to as IP payload. So IP header contains all the necessary information to deliver the packets at the other end. So here IP header playing a very important role, that it contains all the necessary information to deliver the particular packet at the destination nodes. So figure shows IPv4 header format. So this IPv4 is constructed using 32-bit logical addresses as shown in the figure. So that header format contains various fields, and with the help of these fields it is easy to understand the IPv4 header and their operations also. Now let's begin with the different fields of IPv4 header format. So IP header includes many relevant information including the version number, which in this context is 4. That is why we can call it as the IPv4, that is 4 is the version number of this internet protocol. So now let us start with the first field, that is called as a version. So version number of internet protocol use, that for example IPv4. The next field is IHL, that is internet header length, that is nothing but the length of the entire IP header. Next is DSCP, that is differential services code point. This is the type of service which will be provided by IPv4 protocol to the clients. ECN, that is explicit congestion notification. So with the help of this field, IPv4 detects the particular congestion at any particular node which is in the route. So it carries the information about the conditions which is seen in the route. So now next field is total length. The length of the entire IP packets is nothing but the including IP header as well as IP payload. So we can say that total length is equal to IP header plus IP payload. Now the next field is identification field. So if the IP packet is fragmented during the transmission, so all the fragment contains same identification number to identify the original IP packet they belongs to. So if the fragmentation is done during the transmission, so the number of packets are there and that packets contain the same identification number for they belongs to. Next field is a flags. As required by the network resources, if the IP packet is too large to handle, this flags tells if they can be fragmented or not. So in this case 3-bit flags are used, and out of which the first, that is most significant bit, is always set to 0. Next is fragment offset. This offset tells us the exact position of the fragment in the original IP packet. Next field is time to live. To avoid the looping in the network, every packet is sent with same TTL value set, which tells us the network how many routers or hops these packets can cross. At each hop or router, its value is decremented by 1, and when the value becomes set to 0 or reaches to 0, the packet is discarded. Now the next field is protocol. So it tells us the network layer at the destination host to which protocol this packets belongs to. That is the next level of protocol. For example, protocol number of ICMP, that is Internet Control Message Protocol, is 1, whereas TCP, that is Transmission Control Protocol, is 6, and UDP, that is User Datagram Protocol, is 17 respectively. Header checksum. So as its name indicates checksum, it detects and corrects the particular error which is occur in the particular process. So this field is used to keep the checksum value of entire header, which is then used to check if the packet is received without error or error free. Next field is source address. So source address and destination address both are the 32-bit addresses of the source, that is sender, and receiver, that is destination of the packet respectively. Options. So this is the last field of the IPv4 protocol, header format. This is the optional field which is used if the value of IHL, that is internet header length, is greater than 5. So this field is used when the IHL, that is internet header length, is 5. So initially internet header length is 4-bit as per the IPv4 header format, but when it becomes 5, then this option field is in use. So these options may contain the values for options such as security, record route, time, stamps, etc. So this is the various fields through which we can understand the IPv4 header format. Now let's move towards the IPv4 addressing. So IPv4 supports 3 different types of addressing modes. The first one is called as unicast addressing mode. So in this mode, the data is sent only one destinated host. As shown in figure, we have the 3 servers, server A, server B, server C, with respect to client. So client is particularly sent only the data packet to the destinated host, that is server B, as shown in the figure. The destination address contains 32-bit IP address of the destination host. Here the client sends data to the targeted server as shown in figure, that is server B. This is the unicast mode or first mode of IPv4 addressing. The second addressing mode is called as broadcast addressing mode. So in this mode, the packet is addressed to all the hosts in network segment. So as shown in figure, we have the 3 servers again, server A, server B, and server B. So packets are destinated to all the servers, that is server A, B, and C respectively. The destination address field contains a special broadcast address, that is 255.255.255.255. So this is the special address through which the packets are broadcasted among all the servers. When the host sees this packet on the network, it is bound to process it. Here the client sends a packet which is entertained by all the servers as shown in particular figure. So this is the broadcast addressing mode. Now the last addressing mode is called as multi-addressing mode. So this mode is the combination or mixture of previous two, that is unicast addressing mode and broadcast addressing mode respectively. That is, the packet is sent neither destinated node to a single host or nor the host on the segment. So as shown in figure, not particularly any across any server or across any particularly second server or third server respectively, the packet is delivered. So in this packet, the destination address contains a special address which starts with 224.x.x.x and can be entertained by more than one host. So as shown in figure, again we have the three servers A, B and C respectively with the client. So from the client, the packets are shown by dotted line through switch, that is from switch to server A or from server B to switch, and from switch to server B, that is the packets are multicasted through this particular client. So this is the last mode of IPv4, that is multicast addressing mode. So with this I have finished the today's online lecture. So hope all of you understand it. So this is the very much important point for exam point of view as well as knowledge point of view also. Thank you very much.